All right. Um, Fantastic. Welcome to week 3. This is well, this is at the end of week 2. So I hope you guys are feeling okay about the course so far. Okay, it's starting to pick up some momentum, which is really cool. Well, people are joining, so we'll give them a little bit of time to sign into Zoom and all. In the meanwhile, if you have any questions, or concerns, feel free to ask. So today's plan, I was thinking, was to get solid with expressions. And this, by the way, is going to be like super duper useful for, I think it's quest number 2 and 3, I think. Even 4, where you have to calculate things. So we'll do that. And so I have some ideas, and if you have other ideas for calculating things, you should feel free to bring them up, and we can do that. We'll brainstorm later when more students are here. And in the meanwhile, you guys should feel free to switch on your cameras and get ready and start talking to each other. And also, you should feel free to talk to each other about your experiences and whether you're stuck in certain parts of questioning or certain parts of the data representation quiz, or even data representation concepts that you think you need a bit more clarification on, or want to know what your friends' understanding of those concepts are, so that you can consolidate what you already know. All right, so feel free to have that conversation. I'm just going to be here, and let me know if it's just spooking you that I'm sitting here. It looks like I'm watching you, and so you guys are not talking. So I don't want that to happen. Okay, so if it sounds like you just want to have a few minutes to confer amongst yourself, I can just go off screen too, so that I'm not looking at you guys and you can have a conversation. Okay. Thank you, Jason, for switching on your camera. Mia. Ling Chen, is this your first class today? I don't remember seeing you in last week or on Tuesday. Ling Chen? Yes, sir. Okay, all right. Yeah, Ling Chen. Yeah, generally we try to have our cameras on, so feel free to switch your cameras on. This, absolutely free to. Nobody's going to be making any, let's put it this way. None of what we do today is dependent on the image that we have on the Zoom screen. However, people will find that it's useful to click on videos where you have lots of students showing rather than lots of black squares. And I'm just talking right now. Sakshi and Xiangwen too, also switch on your camera if you can. Yeah. All right, just if you guys have any questions and any other things that are standing in your way of making progress, we'll make sure. And I also talked to one of the top tutors in the STEM Center, Lane, and he confirmed that he's going to be on duty this quarter, and he sent me some hours, but he's there. If you go to the STEM Center, you should be able to find him. Lane, by the way, knows the questing system end to end, okay, all the way up to red. And he's done every single thing. And in fact, he was instrumental in shaping many of these quests. Maybe not in 2B, because 2B I did before he came. No, 2A. I've forgotten the history, but he was certainly super duper useful and instrumental in shaping the later quests in blue and green, red and green. So you should absolutely avail of his help. But even better, right? I would recommend that even if you go to the STEM Center and talk to Lane, he knows not to give away the solution, okay? So he'll only point you in the right direction. But even better would just be to ask in the forum. And I'm pretty sure Elaine is also has an eye out in the forum, and he will help you if he sees you struggling, as will I, as will all your other classmates too. And in fact, funnily enough, my 2C students have to complete the blue quest, and some of them are in fact working on the blue quest. So, and therefore the other students who have completed blue and green already, because they get credit for these in 2C, they are looking out for opportunities to help people who ask questions in the blue and green forums, so that if you ask a question in the blue forum, then a 2C student could answer that, and they could get points, right? So he or she could get a more participation points for helping out students in blue also. So you should feel free to converse in the forums. That also treated as a really good way of showing the world that you are of an inquisitive kind, after knowledge. You don't care what other people think, you just want to know. And great. Alexis, is that your camera, or are you is that a static picture? Kiki, what's your you raise your hand?
Yeah, I do have a question. So this is my first time coding the C++, and it's quite difficult for me to finish the whole project myself. And I do have some difficulties in the request number 2. And
so I'm sorry, Kiki, you don't have some difficulties, or do you have some difficulties?
Yeah, I do have difficulties on this. Yeah, the solution part, and there's some errors, and where I can ask these questions or share my part of the code, probably like the errors.
All right. Yeah. So questioning process, are you having difficulty with? Is it copying it in there? Are you able to enter the password and go to the place where you can see that big circle?
Yeah.
Okay.
Yeah. It's my code problem, like my code. When I try to
your whole
code
program.
this.
Yeah, your whole. All right. Okay. No, that's good. Check. Why is my iPad? These things not connecting? Okay. Can someone speak, please?
Yeah, we can hear you.
Oh, yeah. I can hear you here. So it seems to be. Yeah. Okay. Great. That's the battery. All right. So yeah, we absolutely, Kiki. It's a perfectly normal thing to feel in blue, especially early on. And I suspect the biggest difficulty is that it's not with the questioning system. You are trying to figure out how to get a program created and get it to run. Essentially, that's because if you have a program and it runs properly, it will also run in the questioning system. It's exactly the same. So starting last week. Yeah, it was starting last week, but starting last class, but even today and so on. Every class from now on, that's what we're going to do. We're going to be creating little programs, okay? And at the end, I'll say, for your quest, you're going to create a program like this, save it in a file, drag that file into the circle, and press the button. All right. And that's the loop, essentially. And then the questioning system will run the code, and it'll come back with some messages and say, oh, you were successful or not. And then the second place where people have hiccups is when they look at the response and they're not able to decipher what the questioning system was actually telling you, right? So it says you have trophies, and maybe it says, no, you were wrong, but it doesn't tell you where you were wrong. And many people are thrown off by that. So to help you there, you can always, when you get a message back from the questioning system, you can always take that message, copy and paste it in the blue subreddit, and say, hey, I tried to do this quest, and then the questioning system told me this response. What does it mean? Okay, and there will be a ton of people, and if not others, I'll tell you what that means in the subreddit. Okay, so it'll help other people also. So we'll go through the motions, not the entire process of submitting into the quest and getting the results back, which we already did for the very first thing, which is really a simple program, Hello World, in the first class or the orientation video. But we will create more programs that are more sophisticated than that, starting today. And I'll start giving you tips on how you can submit that to the questioning system and get results back
and also show you where to see the results, where your total trophy count for as time progresses, so you can see your total scores there. So don't worry about it. Okay, it's perfectly natural for students to struggle during the initial part of CS2A. And I'm glad that you have identified this issue and you want to overcome that, because especially if you want to go on to do 2B and 2C, you want to get these out of your way. Okay, you don't even want to be thinking about the basic mechanics of creating a file and submitting it. So we'll make sure that's solid. Anything else? Anything else you guys have? Any other question? Hey, Noah.
Yeah, what's up?
Yeah. Okay. So those of you who didn't, and Noah, you too, right? I think you didn't complete your quiz.
Mm-hmm.
Yeah.
Yeah.
Some of you didn't complete your quiz, and it's required to have been completed by Friday. Last
Sounds
Friday.
good.
Yeah.
Yep.
So please send me a note, okay?
Will
Send
do.
me a note. Yeah, send me a note to open up the quiz and also syllabus quiz. They are required tasks, okay? I spoke to Ram and he said we've got to be strict about dropping students in class who don't do the prep tasks. Yeah, I don't know. Maybe there's a spate of false enrollment in all sections, not just my section. Okay, there are lots of students, especially after COVID and the online thing, that enroll in classes under many different names so that they can get financial aid and things like that. And so Foothill is now, I think, cracking down on those things, and we need to make sure, because tomorrow is Census Day. Census Day meaning that we have to submit to the government. But no, I have to submit to Foothill, and then Foothill will basically check these things and submit it to the government. The number of students actually enrolled in each class, because here, and this is where you actually know the value of what you're actually getting, right? Most of you are paying like what, 170, 200 bucks for this class. The same class, if you take it at a UC, you'll be paying something like $1,000 or $2,000. Okay, and if you go to a bigger, a higher profile college, you're going to pay a lot more money, but it's like actually the same material and probably not even taught as well as this, right? So you're going to be paying a lot of money. It doesn't mean that at Foothill it costs less for us to teach the same course. No, it actually costs the same amount of money, because I get a big salary, right? Well, I get a big salary, more than I need. And the room and the Foothill College is in a prime location, right? So and maintenance of the land and maintenance of the buildings, everything costs the same as every other college. So so how do we make up for it? It's because the government pays us the bulk of what you would otherwise pay if you were enrolled in a UC. How much ever you would pay, that much is what is paid to the Foothill College eventually. So what you are given is a subsidized cost. That's the beauty of community college. The community college system is that you can get high quality education for a fraction of the price, because taxpayers pay a great deal of money, right? So all the taxes that people pay. Where I was going with that was that, how did we start talking about that? But essentially, that's what it is. Yeah. So you get a lot of value from these classes. Yeah. Okay. And therefore, the government wants to make sure that the money is actually going to the right people, the people who are actually paying money to learn, rather than just get the money and buy booze or something. So because there are, we did uncover quite a few students who were in previous quarters that were falsely enrolled, and then that was a big source of concern. Okay, so please do complete all the essential tasks, and besides, not only for getting the value out of it, it's going to help you greatly. Doing these things will set you up for great success in CS2A. And as you go on to CS2B, you'll find that it's all even easier. Hey, Jaden, what is your question? You have your hand raised.
Yeah, I just want to ask, will we have some time to live code or like
Absolutely.
question
Absolutely.
queue code? Yeah, I just want to make sure.
Thank you for asking. You want to code today, Jaden? You haven't coded before,
Yeah.
right? Yeah, actually.
Yeah, I've been
Don't
working.
worry, okay? Yeah.
I've been working on setting up each part of each mini quest that was in quest 2. So I've set that up and I just could use a little help with it.
Yeah. Well, we're not going to code your quest. We're going to code
Okay.
some problem will come up in class. And essentially, I'll walk you through it, but you'll find that you don't need me to walk you through it. But other students may call out code that you can type, or you can type ahead, and it'll be fun. So I'm glad you have a decent internet connection, right? And are you a Mac person, or do you have a Windows?
Mac.
Or a
I'm on Mac. I'm using
Mac. Okay,
Xcode.
so yeah, we can actually use Xcode if you like, or we could just go to one of those online sites like LastClass and do that. Actually, let's do Xcode, okay? Let's do, because you're on a Mac. I think a lot of people in class are on a Mac, so we'll do Xcode. And by the way, I didn't see anyone post tips or stuff about getting VS Code installed. I know Tim and I were struggling last class to get VS Code going, right? And then some of you said you produce a video, or so, hey, Shadi, you said you're reasonably familiar with VS Code. Yeah.
I was familiar with VS Code, but the thing is that I wasn't facing the same error that I think someone else was facing. Tim was
Yeah. But Tim's issue, I think, was related to Windows 11, right? But still, it'll be useful if you just post, if you clean out VS Code on your system, if it's possible, reinstall it, and then create a simple program, hello world maybe, and say, hey, this is how I did it. And you can even walk people through the entire sequence saying, I've installed VS Code. I'm creating the hello world.cpp program here. And I'm going to the questing site. And I'm going to drag that file, drop it in there, click the button. And here, I got the results back. And you see that, right? So that entire walkthrough probably will take you about 15 minutes, right? A 15-minute video. And it'll be like super duper valuable. Okay, so we'll probably bookmark it and put it on, pin it in our forum for the first couple of weeks of CS2A, because lots of people will watch it. I don't know, where did Kiki go? Oh, you went to that side. Did everybody see Kiki move to that side? Because she was in the left top corner for me, and then she moved over there. So Zoom shouldn't be doing that, I mean, shouldn't be rearranging people at willy-nilly. So that's really confusing for me. Okay.
It just depends on when someone joins the class that it starts moving people. Maybe.
Yeah, they should just add them to the bottom, in line. And maybe the host will have the option to drag these rectangles around and arrange them in a particular way. Because think about it in class. If I was in class and I was teaching, right, on a whiteboard, and every time someone walked through the door, everybody stood up and then shuffled. Okay, so that'd be like really crazy, isn't it? Like musical chairs. So we don't want to do that.
Yeah.
And so
Also, something's come up. I'm gonna have my camera off, but I will still be here. I will still be here.
Yeah.
I just need my camera.
In fact, since you're going to be coding, Jaden, since you're going to be coding, it doesn't matter if you have your camera off, okay? Because you're going to be live, and your participation is but everybody will know you're here, right? The biggest issue I have with switching off the camera is really most of the rest of the students and I won't be able to tell if you're here or not, right? You can switch off your camera and take a walk. And that is kind of demotivating to other students. So that's another reason. So if you're talking and you're using your IDE or something to code, that's perfectly fine. You don't have to have your camera on. In fact, what I was thinking was I should try an experiment to have my iPad, so log into Zoom on my iPad also, like, who's Huan? Huan's not here? Oh, yeah, he's here.
Yeah, I'm still here.
Okay, yeah, like you had your tablet and your computer on, right, in the first class or something like that?
Yeah, I did. I had no problem with it.
Yeah, so I should try that too, because I tried it in the very first quarter, it worked, and then last quarter it didn't work because SSO wasn't working on the iPad for me. I'll give it a shot later and see if it works. Great. So do you guys have any other questions? And by the way, if you guys are connected to other students who are not in class today via Discord or Slack or some of the other channels, or even if you run into them on campus, you should tell them, right? It's like super duper important to start attending class if they are not attending class, because these participation scores, they will come to bite you at the end. Most people don't realize that. In fact, last week also, I had to send an email to a student who said, I got the grade and I'm not happy with it. And why, can you give me a breakdown, and why did I not get the grade? Because it's, tanking my GPA and things like that. So you shouldn't have unpleasant surprises like that at the end. If you're in class and participative, you're perfectly fine. Okay, so the only reason that most people don't get participation scores at the end is if they are absent in class most of the time, or not posting regular updates and making the class feel, make the class aware of that they are also making progress with the rest of you. I think that is like the super duper important thing, is to just keep everybody aware of the progress you're making. And again, think of it as though this is your work, your job. Okay, in a few months, some of you are going to be working, right? In 2A, I don't know, maybe in 2A, some of you are working already. Okay, but 2B and 2C, increasingly, I have students who are actually professionals in the industry. Okay, they're also doing this, and they're working 9 to 5, and they have a family. And kids and parents to take care of, and they still manage to get very good grades and do a fantastic job. Okay, so yeah, so you should totally tell everybody to participate and take part in class. It's going to be fun anyway. All right. So if you have any questions, we will address them now. Otherwise, we'll just jump right into coding. And what I was thinking we'll do today, and you can correct me, not correct me, you can make a different suggestion. If you have another idea, you can make a different suggestion. So I'm thinking what we'll do is we'll try and calculate, but I have a couple of ideas, right? One, in fact, we should do all of them. We should do all of them. And then Jaden and I will work on one of them. And then after that, I'll say, all right, 10 minutes. Each of you do this on your own, or some other idea of similar to this on your own. And then you're all going to do this for 10 minutes on your own IDEs, create files. And then we'll have an opportunity to share that code and say, hey, that's really cool. That's really cool. So I'll give you 2 ideas. And one of them we'll try and do, Jaden and I will try and do it together on screen. So one of them was calculating the compound interest, okay? Or even, simple interest, compound interest, I don't know. And you can look up, we can go to, you can go to, if you don't know, or if you don't want to derive it, you just go to Google and say, what is the formula for compound interest? Okay. And then it'll just tell you a formula with, the principal and the rate of interest and the number of years, P and R. I think those are the only 3. Are the only 3 determinants, the factors that go into the calculation? I think so, right? Oh no, there's one more factor. So how the frequency with which the interest is compounded. Okay, yeah, okay. It'll all be the formula for sure. Okay, so you'll get this formula, and then you should write a program to you shouldn't do this. Okay, I'm just giving you this as an example. You can't do this, but you pick another idea just like this. Think it up, and then that you can implement. So you'll write a little program in which you're going to ask the user, how much money do you want to invest? Second question, and get an integer, right? And then ask another question. How many years do you want to invest it? What is the compounding period, right? Or interval, or whatever, I don't know what the terminology for that is. And then what is the rate of interest? So you're going to ask these 4 questions, get these 4 numbers, plug them into the formula, and say, this is the total interest you would have earned by that time, or something like that. Okay. So that's actually a cool calculation you can do. And if you're not so financially inclined, what you can implement is we can do a math formula. Okay. So and that will actually help you. We can do a math formula that can help you. So what we can do is we would go to Google. Hey, in fact, Jaden, that's what we'll do, because that's going to tie into what Kiki wanted, which will create a file which will calculate the value of a math function like tan x or sin x. Okay. Everybody familiar with basic trigonometry? Hands up if you're not familiar with trigonometry. No? Okay. So all right. I'll walk you through this. Okay. So when it comes to implementing it, I'll walk you through it. It's basically a formula for something that we want to calculate, but that formula can be broken down in terms of these values as a polynomial. Polynomial is just terms involving x to the power of something. Okay, so if I say sine x, what is the value of sine x? How does a calculator calculate it? Right? You go to a calculator and say, what is sine 30? And it says 1/2. Okay, but how does it calculate it? So the way it calculates it is by using what is called the summation of a long series. So you can break down sine x as 1 plus x to the power of something divided by something, plus x to the power of something else divided by something else, plus x to the power of something else divided by something else. And that goes on infinitely, right? However, the more of those x to the powers you take, the smaller you add on to this. So in other words, what that means is that you get 0.4 plus 0.1 plus 0.005 plus 0.00025 and so on. Each term adds a little bit. That the cool thing about that is that you can say, well, you know what, I don't want the value up to 5,000 decimal places. I'm just happy with 3 decimal places or 4 decimal places. Then you can say, I want to calculate the value of sine x using this expansion, but I'm not going to calculate like a zillion terms. I'll just calculate the first 5 terms and add it together, and I'll get the value of sine x. So it's actually a really nice and a fun thing to do. And what we'll do today in class, Jaden, is to write a simple program to we'll Google for, I think we'll just do Taylor series expansion for sine x or something like that, and then we'll implement that and say, well, if I use only the first term to calculate that, this is what I get. If I use 2 terms to calculate, I get this. If I use 3 of those terms, I get this. And you can see the more terms you use, the more accurate the value that you calculate will be when you use the actual math function. When you say, hey, CPU, or hey, library, what is the actual value of sine x? And it's going to print some big number. Okay, well, not big number, long number. It's going to print a long number. And then you'll say, well, that's how the library calculated it. Now I'm going to calculate it. And you can say, I'm going to calculate it with 1 term. I'm going to calculate it 2 terms. And you can see the more terms you use, the closer the answer you get will be to what the library itself calculates. And then you get a very firm intuition of how the library itself calculates these complex functions like log and sin x and pdx and so on. Now, the reason I think this is going to be useful is because this is actually part of quest number 3. Okay, it's part of quest number 3, where you have to calculate e to the power x. Okay, it's called exponent. Expx is a function in C++ and in many other languages. So, but we won't do e to the x. We'll do sin x or cos x or something like that, some other function. And then at the end you'll have this value, and then I'll say, well, this is what you're going to do for e to the x. And you're going to drag and drop that file, and that will give you your one of the mini quests in quest number 3. Okay, in quest number 3, there's about 2 or 3 mini quests. It'll give you one of those, the answer to one of those. It's all going to be pretty straightforward and simple. Okay, the main thing with the initial stages of C++ is just feeling comfortable with it. Okay, so saying, well, there's no rocket science here. It's all very simple. It's just putting blocks together. I just need to get familiar with the shapes of these boxes, so that I don't put I don't try to fit a round peg in a square hole or something. And that's essentially what we're going to try to do. Is that plan okay with you guys? All right. If you have another idea, we'll try and do that. This is the last class really on just simple expressions, which means that next class onwards we'll have a lot more power. Today, we are still constrained by not being able to use branching statements and loops, right? With branching and statements and loops, the entire power of the CPU is unleashed to you, right? You don't, technically speaking, you don't need anything more than that. Once you have branching statements and loops, you don't need C++ after that. You can do every single thing. You can build a Facebook, Google, Microsoft, the Windows. Everything can be done just using C++ and just using branching statements and loops. Right? Everything can be done. Except it's going to be very painful and long. And this actually goes back to the theory of computer science, really, because a Turing machine essentially codes your entire program just using ones and zeros. Ones and zeros. So anything that is computable at all, anything that you can iteratively compute, anything in the world that has a result that you can get by following an iterative quantitative process like that. Well, it doesn't have to be quantitative. Well, iterative process. Okay, anything that you can do like that, you can do just using a Turing machine theoretically, it's not a real machine, right? Because because even if you want to write a simple program, just using ones and zeros, it's going to stretch all the way from here to Mars or something like that, right? It's going to be a huge program. So it's only of theoretical value, and the value of a Turing machine is essentially just to make the argument, saying that I have a task. Is it basically computable or not? Meaning that if I had a computer, can I calculate it? And so that problem is called computability, and it is a fascinating field in its own, because what we do there is look at different kinds of problems in the world, right? Different kinds of problems, and say, well, that problem it can be computed. It can be computed, meaning I can write a program to solve that problem. Well, maybe not today, or maybe I don't know how to do it, but it's computable. I can prove that it's computable, right? Maybe some other person later on, maybe one of you will discover a way to solve it, okay, in 10 years from now. So, but I know that it's possible, right? Whereas other problems, you can actually say, that problem is not computable at all. How can you say that, right? Maybe it's like Heisenberg in physics, right? When he said, the motions of subatomic particles are not predictable. You can't say with certainty that's what's going to happen, because the very act of looking at a subatomic particle, because if you look at it, it means so you're going to bounce a photon off it, and that photon has go back in your eye. Yes. When you look at something, it's a reflected light from that object that you're seeing. Yes or no? Anything you look at is due to the reflected light from that object entering your eye. That's why you can't see anything in the dark. Yes or no?
Yeah.
Okay. That's why you can't see a black hole. Black hole in space doesn't reflect any light. Everything on it, everything it absorbs, which you cannot see. So Heisenberg said, if you're trying to observe something so tiny that even if you shine light on it, that light is going to scatter it, hit it like a golf ball, and that little photon that I want to look at what it is, it's going to change its position, right? So Heisenberg said you cannot. So you cannot know whether a particle is the velocity of the particle, the momentum, right? The place where it is and its momentum at the same time, because just by looking at it, you change its momentum. So so at that time, so this was a fundamental problem in physics, and so lots of philosophers were unhappy with it, and they said, "Oh well, Heisenberg, Werner, you're saying this because today, back in that day, we don't have instruments that are so sophisticated that you can shine a particle on it and get the reflection back without affecting the particle, right? So you can observe something without changing its behavior. We don't have an instrument so sophisticated that you can do that so subtly, like a feather touch an electron. But the response that Heisenberg came up with was quite remarkable and incredible, and in fact mind-blowing, right? Because anyone who is not mind-blown, meaning that fundamentally shaken by his response, has not really understood quantum theory, because he said, no, we have actually looked at the theory and we can prove that there are absolutely no determinants, meaning that even in the distant future, super sophisticated aliens, right? Even they cannot devise any instrument that is capable of measuring the position and momentum of subatomic particles with accuracy, meaning there's always going to be uncertainty, no matter what. Okay, and so that is a fundamental problem, isn't it? Because that says there are some things at the atomic level that we will never ever be able to know, ever, right? No matter how sophisticated we get, and some events are fundamentally acausal, meaning that certain things are going to happen with no cause at all. That is the part that is jarring to humans, because we cannot accept that. We cannot accept as humans that there are things that will happen with no causes at all. We say, well, there's probably a cause, but we don't know what it is. Yeah. But according to Heisenberg's theory, it's acausal. There are events that are acausal. Things happen without any cause at all at the subatomic level. And how do you get to come to terms with that? We can't even come to terms with that as humans, right? Because we're just used to a causal existence in this universe. And so it's like that. The computability problem is similar, because with Turing's argument, people would raise the objection, saying, well, you know what, these are problems you say are not computable, But in the future, we will have a really, really sophisticated computer that will calculate even these things, which you say are fundamentally uncountable, uncomputable. These will be computed in the future using a future sophisticated computer. Yes or no? Is that a reasonable claim to make? It's a reasonable claim to make, isn't it? Okay, but the beauty of this computability theory, there's the whole theory of computation, is that there are problems where you can prove mathematically that there can never ever be a solution, computational solution. Well, not computational in the traditional way of thinking about computation, right? The Turing machine, the derivative Turing computer. You can prove that there is guaranteed to be no solution whatsoever using a computer so those are called fundamentally incomputable problems. And there's a whole field of study that says, these problems are computable, these problems are not computable, right? And even within the problems that are computable, people have gone to divide it further in, right? So among the problems that are computable, these ones are easily computable, right? These ones harder, these ones are hard. And so we have these categories saying easy problems, hard problems, incredibly hard problems, right? And so on. So and even intractable problems, right? So we have intractable means it can be solved using any means known to us in reasonable amount of time. I think that's what intractable means, right? It doesn't mean incomputable. Intractable means it's not possible to solve it using means that we currently have at our disposal. And so it's I don't know, it's an interesting primer to computability, but this is actually at the heart of all computation, right? And so today, what we'll do is, how did we get started talking about computability in Turing machines? Yeah, but essentially, basically saying that, okay, there are these problems where you can write the program in ones and zeros, and it's really, really long, and it's going to be really painful to write the whole program. That's why we don't use, Turing language to write programs. We write it in higher level languages, and then rely on the computer to turn that into binary instructions, which are still not Turing codes, right? So the binary instructions, because at the CPU level, you still have sophisticated operations happening at the CPU level too, meaning jump here, execute that, and come back here. All of those are sophisticated higher level operations that are already built into the hardware of the CPU, right? So we will see how we can exploit all of those features to come up with interesting, incredible solutions to our problems. Okay, so Jaden, whenever you're ready, just pick up the screen and share your Xcode window with us. And then in Xcode, what we'll do is we can create a file today. We can create a file, and then we'll do the same thing as last class. Okay, like we did with Tim. We'll put some comments at the top saying, well, this is the code for Thursday's class, and we're going to try and calculate some expression and print the value. I think that is reasonably, well defined enough for us to do today. Yes, is that okay with you all? Right. So you should give me some feedback, okay? Because
Yes.
if you think, thank you.
Yeah.
All right.
Talk to American draw cat.
Yeah. All right. So let's not go into those because that's your Quest code. So what we'll do is create a new Xcode project. Okay. It's got to be a command line tool, and and then language C++. Yeah, well, it's just picking up your own defaults, right? You've been doing those quests, and you've already set it up this way. Fantastic. All right. So what shall we calculate? I'm going to leave the compound interest thing in your hand because I can guide you later on if you're stuck. All you have to do is really go to Google, look for the formula for compound interest, and then it'll say, oh, this is the formula for compound interest, P times 1 plus NR to the N or whatever, right? So it'll give you a formula. And then all you have to do is take that formula into your program and say, well, this formula has P, N, R, T, and so on. I'm going to ask the user, what is your principal? What is the rate of interest? And so on. Get those numbers, plug them into the formula, calculate it, and print the result. Okay, that's all you have to do. But we'll do something very similar. But this is going to be more similar to our, Quest that you do later. All right. So what name did you give it, Jaden?
I gave it compound interest.
Oh, no. So compound interest should be your own and other people. Leave this project alone, but create a brand new project. Today, shall we do just sin X or cos X?
Yeah, it's just named compound interest. It's just I just named the compound
Yeah, yeah, yeah.
interest, but it's just in the project.
Oh, yeah, yeah. So any project you create, this is what you're going to get. Okay. Any project you create, this is your boilerplate code. It says, okay, your project is ready and this is your main file. And it gives you a sample main that's already pre-filled. This is what you're going to get. So this is your compound. And what it means is that you have to go into the file and now flesh out the rest of the file with compound interest stuff. Right now, we'll do the same thing with the other thing, with the other project. I'm thinking, let's calculate the value of sin x, right? Sin x or cos x or one of these mathematical functions. How about sin x? Sin x, okay?
Yeah, that's fine.
Yeah, the sine of an angle. If you have a triangle, a right angle triangle, the sine of an angle is essentially the opposite side of the angle divided by the hypotenuse, right? So it's I don't know. All right, okay, I can do this. Okay, so it is the opposite side is the vertical one, and the hypotenuse is that one. Okay, so you take the length of the opposite side and divide it by the length of the hypotenuse. That is the sine of this angle. And the reason it's important is because no matter how big your triangle is, it could be that, no matter how big your triangle is, that division, that ratio is always going to be the same as long as the angle is the same. That's why the sine, these are trigonometric measures, and they help us greatly in a whole lot of things, right? Not just in construction business, they help us greatly. So that value, the sine of the angle, that's why it's important, and we can calculate that. So can you create a brand new project? You can click the red circle there and close this, and then go to File, and this is what you'll do, most of you. So you go to File, and yeah, all right, there we go. Create new project and call it sine, S-I-N-E, right? S-I-N-E .cpp. And by the way, all right, we shouldn't be doing this just because it's my idea, okay? Because I came up with some random idea that I pulled out of air and thinking, well, this is what we're going to do today. Chances are that some of you may have better ideas, better things to code and play around with today, which may have more exciting opportunities for variations that we can inject and talk about, okay? So please feel free, right? If you have a different idea for something else that we can calculate, which doesn't involve looping and branching, simple things, right? Just a formula, plug in the values and calculate it. That's all we want to do, right? So you can use Google if you want, look for things, and we can do that too. Or you can save that for after Jaden and I finish this. When you get your time, you can Google and find out. And then after that, when I come back, we can do a round robin, like go from person to person, and each of you gets a chance to have your code up on screen for about 2 to 5 minutes, and say, hey, well, this is what I calculated, and let me run it, and this is what it runs. Okay, this is how it runs, and so on. So
I had a question about code signatures. If you can maybe do that with Jaden as well.
Oh yes. Juan, did you ask that question in the forum?
Yes.
All right, thank you. Yeah, we'll cover that in class today. Okay. Thanks. All right. So you got your main wow. Did you rename that to sign.cpp, or did it actually call it sign.cpp?
When I put in sign.cpp, that's when I renamed it.
Oh, you did rename it, right? Because the default was main.cpp, wasn't it?
Yeah.
Ah, good. Because the last time someone shared the screen, it had main.cpp, and I thought Xcode couldn't have changed its behavior so quickly. All right, so get into that file. Click on sign.cpp. Oh yeah, actually no. Oh no, actually, you know what, Jaden? You named the project sign.cpp, not the file. So
yeah.
So click on that right, main should be called sign.cpp, and then the project should just be called sign, right? So call the project just sign, not sign.cpp, because it's not a CPP file. That's the name of the folder. It's not a CPP file, right?
Right.
Yeah, just single click on it. It'll let you rename the folder. Single click on sign.cpp.
There we go.
Oh, there you go. All right, now this is sign.cpp. Great, fantastic. All right, so this is our file. So right at the top of the file, let's put in some comments. Well, you have sign.cpp. Yeah, that's fine. After on line 3, hit enter on line 3. Let me change my glasses, okay? Because the font is getting too small for me. All right, so assign. Oh, great. Oh, all right. So here we're going to say, let me put today's date if you want. Code, a class code for, put in comments. You can say class code for, what is it, April 13th today?
April 14th. It says
So,
It
so
has to
say,
do-
oh, you have to open a comment. So 2 forward slashes there, just like the previous line. Yeah, and then space, and then class code for April 14. Okay, now under hash include IO stream, let's also say using namespace, so it'll save us some typing. Yeah, using space namespace, using space namespace space standard semicolon.
Wait, what was it again?
Yeah,
The last one?
std, and then semicolon, and then enter. And you can also put a blank line above that because you have the include files there. We want one more include file. So hash include, and then what we want to do is we're going to calculate the value of sign, but we want to check it against what the library is going to calculate, right? So to see if our calculation matches the library's calculation. So we're going to invoke the library, the math library, which has been given to us, to say, hey, math library, what is the value of sin x? So in order to use the math library, we're going to have to hash include math, M-A-T-H, and then close the angle bracket. Okay, enter. Okay, so that, and put a comment on the line 10 after hash include math. Why
Math
does it
is
have
not
an
fun.
underline there?
Yeah, math is not
most
fun. The math file is not fun.
Okay, type C math. Okay, so all right, I'm sorry that had to happen, because I don't want it to be throwing you guys off. See, math.h, the actual file is called math.h. Okay, but in C++, you can sometimes just say this and the compiler figures out what the file is. So I said math, which is what you would have typed too, but unfortunately it is C++ requires you to say C math, because this math library historically was created long before C++ came into existence. This math library you're using was part of the C language from a long time ago, before C++ came, before Bjorn Schuster dreamed about C++, people were already using the math library. Okay, so so it is the C math library. And so C++ wants us to make this distinction, saying, well, you want to include this file, this library, so call it C math and not math. Okay, so I don't know, it's a piece of trivia, yeah, unrelated, but unfortunately we have to cover that now. Okay, so blank line there, we don't need the comment open. Blank line is just fine. Yeah, get rid of the comment. Yeah. All right. Now under using namespace standard, we'll go into blank line there. And then here, what we're going to do is create a function of our own, which is going to calculate the value of sin x, okay, and return it. Now, we have not covered functions and parameters and so on and so forth, okay? We will cover that in week 5. However, in my opinion, C++, most programming languages are so intimately connected to functions, right? Meaning that anything you want to do, you got to call a function. In fact, main itself is a function. Right? Which the operating system calls. So everything is a function. So I'm thinking, let's start using functions right now and get used to what they do. And then in week 5, we'll get a much better understanding of why, what they do works, or how they do what they do, right? So in week 5, and I think that's always a better way of learning anything, is to first learn to use it, so we know the utility of it, and then figure out how does it do it. That comes later, right? So if you don't know the utility and try and figure out how does it do it, my motivation anyway, I don't know about you guys, right? My motivation for learning something that doesn't have a utility is correspondingly lower. So you're going to have a harder time trying to learn something before, knowing the utility of it. So we're going to use functions already, and slowly as time progresses, before week 5, your understanding of functions will start increasing, all right? And by the time we come to week 5, you'll be really solid on functions, okay? So now hit a couple of blank lines there, Jaden, and then we'll go back to line 14, and that's where we're going to define our function. So now start a comment there. and say, we're going to define a function. We're going to define a function to calculate the value of the sine of an angle. Okay. Angle. Now, open a tab in Chrome. Open a tab in Chrome and go to just type in there, right there in the URL bar. Type in Taylor series expansion for sine x. All right. I think that should get it. Taylor series. Hey, Jaden, you're a math student.
Yeah.
Are you? All right, because you type TAYLOR immediately. So that's cool. All right, so just click that. We'll just pick up that formula. Further down, I think we'll see the formula. This is a derivation. Let's not worry about the derivation. There you go. There you go. Okay. So there you go. Yeah, there I see that. X minus x cubed over 3 factorial and so on. You see that? Okay.
Yeah.
So that's a formula we want. So now, so hang on. Odd terms have negative sign. Even terms have positive sign. No. Oh, they're all odd terms. And then starting at x cubed, the minus will alternate. Okay. So this is what we want to do. All right. So now let's go back to our program. Now, let's flesh out the comment and say the series is on the next line. You say on the next line. We'll use a series. We'll use the Taylor's. We'll use a series. We'll use a series. Use the expansion. Let's say expansion. For sin x from the Taylor series, right? Taylor series. Use Google or something like that, right? You can put in parentheses. You can say use Google. But on the next line, we'll say what the formula is also. All right. So on the formula is you say sin x equals. I think it's 1 minus x to the 3 over 3 factorial. So because x to the 3 over 3 factorial. So
what's the
the divide sign is a forward slash. A 3 exclamation mark. Okay, 3 exclamation mark. Now the factorial. Does everybody know what a factorial is? Not just the math students. Okay. All right. So those who are not math students, Mia, you said you were not comfortable with the thing. So do you know what a factorial is? I can explain now. Okay. Don't worry. A factorial is actually very simple. Okay. A factorial is simply the product of all numbers up to that number. So if I say what is the factorial of 7, the factorial of 7 is 1 times 2 times 3 times 4 times 5 times 6 times 7. That's all. Okay. It actually has a lot of uses. Because the factorial of a number is simply the number of different ways in which you can arrange something, right? If I gave you like 3 numbers, or 3 letters, A, B, C, and I said, how many different ways can you arrange A, B, C? Say A, B, C, A, C, B, B, C, A, B, A, C, and so on. Yeah, many different ways. But how can we know how many different ways there are without actually writing them out and enumerating them? It's actually easy to find out. It's actually the number of these things factorial. So ABC is 3, and so 3 factorial is 6 because it's 1 times 2 times 3, and 2 times 3 is 6. So the number of different ways you can arrange 3 letters is 6. So that is one of the greatest uses of factorial, is to find the number of, it's called permutations, number of permutations of objects. Okay, and in fact, any of you who have not enrolled in discrete mathematics, it's a hard course. Okay, it's a relatively hard course, right? It's not super hard. I think at Foothill, Patrick Morris and Charles Wicherick, right? Two profs I know. They teach this course. I would highly recommend, okay, enrolling in this course and doing them, because I know they're both really great teachers, because that's where you get to learn all of these things, permutations, combinations, and how these play into computer science, because these will eventually come into our world and say, well, you know what, this algorithm, how efficient is it? And in order to find out how efficient it is, you need to find out a certain number of permutations and so on, right? So all of this will factor in to computer science to help you devise and invent these really cool ways of doing things with computers, all these discrete mathematics things will help. So anyway, so what we'll do is, minus 3 factorial, and then space plus. I think it's x to the 5 over 5 factorial, x to the 5 over 5 factorial, right? And then minus x to the 7 over 7 factorial, right? And fill in the next term also. So let's say we are going to do, in fact, we'll do a, fill in the next couple of terms, right? So that means we're going to use 5 terms. Let's say we use 5 terms, okay? So go ahead. You don't have to wait for me. It's going to be plus. Oh no, yeah. Let's no. Yeah, it'll help to not look at this and just do the pattern from our mind, okay? So what's the next one going to be?
Would it have to be plus 9 x to the 9?
Yes. Go ahead. Type it. Yeah. So plus x to the 9 over 9 factorial, and then we'll also do 11. Okay. So one more term.
Jaden, you might want to put the exclamation mark after the 9.
No, 7, right? Also 9. Okay, I see. Cool. All right. Now I'll also do the 11 x to the 11 term over 11 factorial, and then what the next one is going to be plus, right? So just put the plus there, and then dot, meaning that the value of sin x is not just determined by these guys. There's a whole lot of more terms to come, all the way up to actually infinity, right? There's a whole lot more terms to come. We're not going to use them. That's what it means, right? So we'll only use as many terms as our computer can handle. Are we okay with that? So what we're going to do now is in the function, let's create the function now. So on the next line, we're going to say, double. No, not a comment now. We're actually going to define the function itself. Yeah, so double space, and let's call this function, which is not the library's function, it's our function, right? We're going to say my underscore sign, okay? My underscore sign, my underscore SINE. Okay, and then it's going to take a parameter, so open parentheses. No, it's the open parentheses.
Oh,
no semicolon, open parentheses.
Okay.
Right, and then it's going to take a parameter saying what is the angle. Okay, so it's going to say double space x. Okay, so this is going to return the value of the sine of angle x. That's what it means. Okay, so in fact you can put a comment there saying above the function saying this function return on the previous line open a comment, on the previous line open a comment. Yeah, right. This function will return the value of the sine of x.
Hey, Professor, I have a question about syntax. Is there a rule for using camel case versus the snake case?
No, I don't think there is a rule. The only thing that most programmers don't like is if someone mixes both of them in the same program. Because I don't know, I should take that back because I have seen really good programs in which people have mixed those, but usually they are outliers. Just pick one and just, if you're consistent in your style, that's fine.
Okay, thank you.
Does that answer your question?
Yeah, thank you.
All right. There you go. This function will return the value of the sine of x. Great. I'm thinking let's not. Yeah, we'll return it. We'll return it. Okay. Should we return it?
Return it to 0?
No, I was thinking, should we return it or basically print the values right here in this function? All right, so we're going to do some couts. So the reason I was deliberating is because, think about it. This is a function that's going to be called to say, give me the value of sine x. Now, would you be happy if you asked think about you're the manager of a car mechanic shop. This is the analogy I use every quarter, in fact, right? So you're the manager of a car auto mechanic store, and a customer comes in and says, I need my car to be fixed, and they fill in the paperwork and go away. Now you take the car and say, call your mechanic and say, this car needs to be fixed. Can you fix it? Okay. Now, how would you be happy if that person took the car, fixed it, but then got in touch with that customer, right? Directly, not through you, and said, well, I'm talking to you, I'm working on your car and things like that. That kind of thing doesn't happen, right? Because if that happens, things are not going to happen. Things are not going to be streamlined in that store. People are talking to everybody, and it's a big mess. So the way things happen in life is that there's usually centralized points of control, and one person says, all right, you know what, interacting with customers is such a real pain in the ass, so that I'll spare the people on the floor the pain of having to talk to these problematic customers, because customers are always, many times they come with problems, right? My car is not working. So they say, I'll save you the bother of talking. So there's the receptionist or the manager who talks to the outside world, and the mechanics are spared the trouble so that they can focus on their work and get the job done. And likewise, sign is a function that main calls. So main says to sign, calculate the value and give it to me. So that being the case, sign should only calculate the value and return it to main. It should not go ahead and print things to the console and say, I'm in the process of calculating things, I'm also printing stuff here on the console. That is a total mess. Because if that's the case, nobody will use your function, because they don't know, if I use this function, is that person going to print random shit on the screen? Yeah. So these are called internal functions, and internal functions should not talk to the user. Internal functions should just do the job. And so for that reason, I was reluctant to say, well, are we going to have cout statements in here? But we're going to break that sentiment here because of certain factors, right? Because we haven't introduced looping and things like that. Maybe we'll come to that towards the end of the class, right? Let's put a comment above this function. One more comment, please. Yeah. In this function, we're going to do something unconventional, which is to use cout to talk to the user directly, even though this is an internal function, right? And then we can say, don't do this in professional code, right? Something unconventional or not recommended, right? So you can say that, just so that people are, everybody who's watching this video or following this code know that's what they're, right? Not recommended, because on the next line you can say, because this is an internal function, not visible to the external world. On the next line, yeah. Oh, did it go? Yeah, it wrapped, but you need to break the line so that you get the comment thing and all. Yeah, because this is an internal function, not visible to the external world. Does that make sense? Okay, all right. Now, this line 20 here is what is called the signature of this function, okay? Where's Juan? Oh, there he is. Hey, Juan, you haven't got your camera on, so I can't tell immediately if you're here or not. Okay, so I got to read all the names. Okay, so are you here, Juan?
Yeah, I'm here. I'm at a desktop with no computer, no camera.
No, that's fine. I just wanted to make sure you're here because we're talking about signatures now.
Yeah, okay, thank you. Yeah.
All right, cool. So that line here, line 20, is called the signature of the function. Why is the signature of the function basically tells the compiler a few important things about this function. It says this function, when you call it, you have to give it an X value that is of double type. Okay, you're going to say it's going to take a parameter called X. When you call this function, you're going to give it an X, which is a double value. And when this function ends, it's going to give something back to you, and that's also going to be a double value, right? And this is the name of the function, nice. So these three things are like super duper important for the compiler to know. Why is it important for the compiler to know? Right? So this is, and that's why it's the signature, and the signature is like super important. Now, even though this function is defined here, the compiler, as far as the signature goes, does not, at the time it's building, compiling your code, does not want to know the entire definition, how it does its job. I don't care how it does the job. I just need to know what the signature is. Meaning, I just need to know. The compiler says, at the time I'm building out your binary version of the code, all I need to know is all the functions you use. Just tell me what they take and what they give back. Okay, that is like super important, because in order for the compiler to do its job properly, it needs to take everything that main gives that function and give it to that function, and take everything the function produces and give it back to main. Yes, otherwise the function is not going to work. So it needs to get everything that you give it. Now, what happens if you said to the compiler that, this function in the signature, it takes a double parameter, double meaning x is of value is of type double. Now, the double data type from data representation, is how many bytes in C++? It's 8 bytes long, right? The double data type is 8. An integer is 4 bytes. A character is 1 byte, right? An integer is, and a short integer is 2 bytes. So every different data types have different sizes. And later on, you're going to be creating your own data types. And some of those data types may have, big sizes, arbitrary sizes. But the primitive data types that are given to us by the compiler already have fixed sizes. And the double has 8 bytes. Now, if the compiler didn't know that when this function is called, I need to take 8 bytes of what the user gave me and give it to that function, and it thought instead that, that function probably needs an integer, I'm going to take these 2 bytes and give it to them, right? Then you gave the function 8 bytes, but the compiler only took 2 of those bytes and gave it to that function. So can the function work properly? No, right? Because you told it, this is what I want to be processed. But the compiler would say, well, I didn't know the signature of the function, so I assumed that it was going to work on an integer. So I just took the 2 bytes off the top, because that's my integer. Because an integer is only 2 bytes, but the double is 8 bytes. Does that make sense?
Yeah. Yes. So with,
all right,
like, as an example, the void cat, it would be voiding at the end.
Yes, exactly. Okay. So when a function does not return anything back to you, it says, I'm going to do something, but I'm not going to give anything back to you, that means it's void. Okay. It says, when I'm done, I have 0 bytes to give back.
Okay.
Yeah. But on the other hand, you can have a function that says, when I'm done, I'll have 8 bytes to give back. It's a double. When I'm done, I'm going to give back a string. When I'm done, I'm going to give back an integer. That's only 2 bytes. So the way we tell the compiler, this is what the function is going to do, is the signature. Does that make sense, Juan?
It does, yes.
Okay, great. Now, if you have time later on, you can basically. Did you ask this question in the subreddit or in something else?
In the subreddit.
In the subreddit. If you have time later on, it would be great if you can basically summarize that, and for the benefit of other people, because we didn't answer that question in the subreddit. So you can basically say, well, in today's class we discussed this, and this is this is what a signature is. And I think a whole lot of people will appreciate that.
Okay.
If you have time. Thank you. All right. So let's go into the function now. So that is the declaration line. The signature is the declaration line. That is the place where the function is declared. Okay. The declaration of a function is different from the definition of the function. The definition of the function is the body. The definition tells the function how to do what it needs to do. The declaration basically says, this is how you're going to look to the external world. Okay. So now let's do the definition of the function. So put a space there where you have the cursor, put a space, and then curly brace, space, curly brace, and enter. All right. And then, we'll put a couple of spaces there because we're going to fill it in there. Blank lines there. We're going to fill it in. Okay. So, all right. So we've got X, and we're going to use that to calculate. But before we do that, we'll put a comment there saying, first, let's print out the value of sin X according to the system library. Okay. First, let's print out the value of sin X. According to the system library. Okay. So and let there's an apostrophe before the S, but you can fix it later. Okay, let apostrophe S, but that's fine. All right. So here, what we're going to do is all right. So here we'll say C out, right, and then space left shift. No, left shift is the two less than signs.
Oh.
Yeah. Space, and then within quotes you can say sign, open parentheses within quotes, right? Open parentheses within quotes. Or you can say sign off. And then because it's not a function, you just say SINE instead of SIN, because SIN is the name of the function, but the actual word is called SINE, sign. So sign off, one F, sign off, and then space, close quote. No, you need a space after the off, right? These are things you'll discover when you run it the first time. You'll discover you need a space, but I'm just telling you right now, right? Close the quote now, and then left shift again, and then say X, left shift X, right? Now X, because X is what's given to us, yes, right?
We have an additional semicolon above.
Where is the additional semicolon? Oh yes, thank you. Who was it? Xiangwen?
Yeah.
I thought I recognized your voice. Thanks.
So I don't need this or
someone else said something.
No, so I don't need that semicolon.
Yeah, you don't need the semicolon there. Yeah. Okay. Now, and then do a left shift again after the X, left shift, and then open quotes again, open double quotes. Open, yeah, and then space, degrees, right? Or radians. Let's say radians. I think you got two spaces, but that's fine. Okay, now radians is another way of measuring degrees. So Mia, degrees, in the protractor you have 0, 90, so on. Radians is just another way of measuring angle. So radian. And before you close the quotes, you say equals, and then space after the equals. All right. Now, and then outside of the quotes, say left shift. Now you're going to say SIN, open parentheses.
Oh, okay.
No. What you typed was correct. No, not within quotes. This is
sorry. Okay, sorry about that.
Yeah. Now, open parentheses, not quotes. Open parentheses. Yeah, and no space before the parentheses. Yeah, sign.
Okay.
X. Right. X, not 9. Is it 9 or X?
Oh, okay.
Oh, 9X.
Sorry, I'm just saying.
Yeah. No worries. Okay. And then afterwards, you do an left shift and endl. ENDL after that. Yeah. Semicolon. ENDL. Okay. Now semicolon right there. Now so here's one of the cool the important things that is very useful in programming is every time you got something that you want to incremental testing. It's called incremental testing, meaning we've got something, let's make sure it works before we go on to the next step. Okay, so let's make sure this works before we go on to the next step. Now let's go to main and invoke our function. Okay, so in main, go to your main method and then get rid of the hello world. No, you can, all right, okay, that's fine. Now you can say cout, right? Double left hand, left shift again. And then you can say sign, you can just, actually you don't need cout because a sign is going to print, right? It's also returning a value. All right, so all right, the cout that we stuck in there is kind of unconventional. I don't want it to inject any bad habits into you guys. Okay, all right. So what we're going to do is all right. So we'll just call our function right there for now. Okay, we say my underscore sign, and then say give it an angle. Let's 30. Give open parentheses 30.0. Oh, it can't be 30.0. It's got to be pi over 2. Sine pi over 2 is 90 is 1, right? So pi over 6. Okay. So what we want to do is m underscore pi, all uppercase, m underscore pi.
Inside the
Oh, there you go.
parentheses or?
No, inside, right where you got it. You see the autocomplete? Okay. You got m underscore pi right there.
Yeah.
Yeah, that one. That's what we want. Just click that. Right. Divided by / 6.0. Hey Nate, you got an LED. Hey Nate, you should just feel free to talk, okay? Because I just by chance I saw the chat message. Most of the time I don't even see these chat messages. Major project you're working on. Let's see, it has simple loops, but very interesting. Oh, great. Okay, yeah. No, in fact, you can give us a preview during class also, Nate. Yeah. So after this, you can do a preview of that and explain, show what that's going to be really cool. Okay. All right. Let's. How do I get rid of this? All right, cool. All right, so what that is essentially going to call your function. Why is the indentation all screwed up? Why is this to the left and return to the right? So can you line it up so the indentation is correct? Not there. My sign. You're calling, yeah, that line. I think line it up with return. One more space there, and then put a blank line before return also, so that return is separated out. All right, so this is going to call semicolon at the end, and go to our double my sign function there. And for now, at the end of the function, in order to get it to compile, we're going to say return 0.0. Okay, return 0.0.
0.0 or just 0?
0.0. It's useful to say 0.0 because it's going to return a double, not an integer, right? Even if you say return 0, the compiler will convert it into a double because it knows the signature. Like, that's where the signature is useful, because the compiler knows the signature of the function says it's got to return a double. In the function, you can say return 0. And because the compiler knows the signature says it should return a double, it'll convert 0 to a double and return it, right? But let's not bank on that and say, well, we're just going to return 0.0. Now, so that is not the real value, right? That is not the actual value. The actual value should be the computed value of sign. We're just putting it there so that the compiler will not complain, saying, hey, this function should return something. It's not returning anything, so I'm not even going to compile it, right? So to prevent that, we're going to say just return 0.0 and put 2 comments there and just say a stub return for now. Put 2 comments there. Right on the return line. On the return line, at the end of the return line, just put a comment saying, on the same line. Yeah. Put a comment saying it's just a stub return to be replaced later. Stub. That's what a stub, right? It's called a stub. Stub meaning you're putting it in place, but that's not the real value. You're going to change it later on. When you got the full function working, you're going to change it. That's what stub means, right? In your programs, as you write bigger and bigger programs, you're going to be creating lots and lots of functions. You can't wait for all of the functions to be implemented before you compile it and test it, right? So what most programmers will do is when they create a large project with many functions, a lot of these functions will just have stub returns saying, well, the function's body is not fleshed out yet, but it's got to return a double. This one's got to return a string. This one's got to return an integer. So even though we don't know what it's going to return, the compiler needs to put them all together so that I'll make it return a 0. I'll make it return an empty string. I'll make it return, right? So it'll just say, programmers will just put in dummy values there so that the compiler will not complain and believe that they are the real values, and put the whole thing together. And then they'll say, okay, now the whole thing is working. Now the person who's responsible for this function, now you can go and implement the whole function and then change the stub to the actual value. So that's how the project basically comes together. Big projects, that's how they come together. Okay, so now if you compile and run this, we should actually see the value of sine of pi over 6. That is pi over 6. Is pi over 6? What is pi over 6? is 30. Isn't pi over 6 is 30 degrees, isn't it? Because pi is 180. Pi radians is 180 degrees, right? Pi is 180 degrees. Pi over 6 has got to be 30 degrees. Yeah.
Yes.
Okay. Are you guys uncomfortable with math terminology? I mean, if you are, we can try and find another thing to work on. But you know, it is all very straightforward. And hopefully this will also make it easier for you in other classes in math, for example, because you're already getting, you know, the double exposure to these concepts, I think. Right. So, but if you want, we can use other examples that don't involve these things. So pi, is everybody comfortable? Right. Okay. So now if you compile and run this, we should see the value half, because the sine of pi over 6, the sine of 30 degrees is actually half. And you can draw a triangle. Okay. On your any piece of paper, you can draw a triangle. You take a piece of paper, draw a triangle, 30 degrees, right angle, and you measure this side and measure the hypotenuse. You'll find that this side is exactly half the length of the hypotenuse. No matter how big the triangle is, no matter how small it is, you'll find that it's exactly a half. Okay, so if you run it in the console, you'll see the sine of pi over 6 radians equals, right? You should see a console there, and it should say 0.5. Oh, maybe it says 0.499999. What? Oh, it is. Okay, I was looking at the first number. Okay, so that is pi over 6. Okay, pi over 6 is 0.52 because pi is 3.14. 3.14 divided by 6 is 0.52. Right. So it says the pi sine of that is 0. Now what we want to do is that is a library's value, right? So sine of, okay, right. Let's change the, yeah, now let's go to line 22. Let's go to line 22. Radians, we want to say, somewhere there, we want to say, this is not our value. We didn't calculate it. This is from the library. So we want to say, in parentheses after radians. After radians, you can say in parentheses, calculated by the library, right? Calculated by the system library. Calculated by system library. Oh, you can just say system library. System library. It's too long. You say system library. Yeah. Okay. And close the parentheses and put a space before the parentheses too, because now it looks like a function in radians called with the system library string. So put a space before the open parentheses there, so that no, before after the word radian. Yeah, put a space. And then, you know, from a change system to from system. So it's from system library. I think that sounds better. From system library. Okay. Now we're going to calculate the sine according to this expression that we have using one or more terms. Okay. So on the next line after that, so we're going to say the value of, so one more blank line, and start a comment saying, yeah, one blank line after the blank line, a comment, yeah, put a comment there saying, we can say calculating using one term, calculating using only the first term, calculating only using the first term. Okay. All right. Now we're going to say on the next line, you can say double val equals equal. Yeah. And what is the very first term of that series?
Would that have to be X or
1?
Yes, it is 1. Okay. The very first term is just 1. So we're using only the very first term, and we're going to say, all right, 1, val equals 1. Semicolon. Right? Semicolon, enter. Now, triple click line 22 and paste it right under there. Triple click line 22.
line?
Yeah.
Oh, oops.
Triple click. And command C right there. And then go to line 26 and command V. Okay. Now change from system library to the within parentheses some from, yeah. Change that to using one term. Using one term. Equals And then you're going to say val right there. Instead of sin x, you're going to say val. All right. Now copy lines 24 to 26, all three lines. Yeah, triple click and drag. Triple click on line 24, and then drag without releasing. Yeah. Go. Yeah. Now copy the whole block one more time after a blank line.
Okay.
Yeah, put a blank line after that. No, a blank line there. Blank line. Now paste it again. Yeah, great. Now change using the comment line 28 should be using two terms. Using not the first term, using two terms.
The series should be X. The first term should be X, not 1. I think it's
Are you sure?
mistyped. Yeah.
Oh, wow. I didn't realize that. Hey, can you go to that page that we had before, the expansion? I was surprised. Oh, it starts at 0. Yes, you're right. Thank you so much.
Yeah, no
All
problem.
right. Yeah, who said that, by the way? Michael?
Yeah.
Thanks.
So it
Yeah,
should be 0.
It should be 0. Yeah. And we should also correct the comment on line 16. Line 16 shouldn't be 1 minus, should be 0 minus. Is that correct, Mike?
It should be X. Sorry, X.
Oh, I'm sorry. It should be X. Yeah. All right. So val equals X. There you go. Thank you. All right. Now you've got that. Now two terms. Plural terms.
Yeah, what's happening here? Redefinition of val.
Yeah. Because what that says is that, hey, you want to use a variable called val, and you told me that you want a variable called val and should be of type double, and I've given it to you. Now you're asking me for another variable also with the same name, but I know you can use val again. So what we can do is we can use it, but not tell the compiler to give us another variable of the same name. So all we have to do is just get rid of the double word in front of it. So get rid of the word double in front of it. That means we're just reusing the same variable. We ask the compiler for a val, which is double, and we're going to use it many times. Does that make sense? Instead of asking it again and again for the same thing. Okay. Now here, val is not equal to 1, right? Val is going to be X on line 29. On line 29, right? Now val is going to be X minus space minus. Now we have X cubed, right? Now let's not call the math function pow, right? There's a function called pow which can take a value and raise it to some power. Okay. No, let's not do that, because if you do that, you'll get a quest wrong. In quest number 3, you have to calculate the mathematical expression, and it says don't use the math library. You shouldn't use the math library. So we're going to do it without using the math library. So here we say about x times x times x, right? X times x times x. No, go on, right? Why? All right, cool. Right? X times x times x. That is x cubed, yes? Over 3 factorial. Again, let's not call a function to do our factorial, right? Over, yeah. Now, the denominator should have 3 factorials, 1 times 2 times 3. Now, because it's a product of 3 things, let's put it all in parentheses, okay? Open parentheses right there. No, not like that. So no tweet. Just open the parentheses right there. After the forward slash, immediately after the forward slash.
Oh, okay.
Open the parentheses. Yeah. So you say 1 times 2 times 3. Even though it's 1 times, let's just make it clear so that we know it's a factorial. 1 times 2 times 3. 1 times 2 times 3. All right. So that's 2 terms. That uses 2 terms. Is everybody okay with this so far? Okay. Now, yeah. Now change the next line also. The sine of x radians using 2 terms. Using 2 terms. Okay. Now copy the whole thing and let's do 3 terms. No, you got to get the comment. Yeah. All right. That's fine. That's fine, because our code is self-documenting. You don't need a comment, right? So put it there, right? Now you say 3 terms, and then we're going to change the expression also. Val equals, yeah. Yeah, plus, at the end, you'll say plus. Not there, before the semicolon, So you still need the x minus,
Oh, okay. X minus
right? And at the end, before the semicolon,
plus.
say plus. Now it's going to be x to the 5, right? Now, at some point, it's going to get painful because you're going to have lots and lots of x, but we'll still use it. Even though it's painful, we're going to use it. X times, x times, x times, x times, x, right? Five of those. Now, I can tell, someone has to verify for me. Is there 5 x's there?
1, 2, 3.
Yeah,
Yeah.
there's 5.
Okay. Now, within parentheses, you can say 1 times, 2 times, 3 times, 4 times, 5. Okay. All right. And semicolon. All right. Now we want to change the comment. Oh yeah, that's fine. Do you want to do one more? Let's also do one more. It'll be nice. Okay. Let's do one more. 7 terms. No, 4. What is it? 3 terms. 3 terms. 3 terms. Oh, 4 terms. 4 terms. Let's do 4 terms. Okay. Hey, something is wacky here. Yeah, no, that's correct. That's correct. 4 terms, right? So now you want to do minus. Yeah, and it's got to be 7 x's now. I don't know how we're going to do that. Yeah.
Okay, so
what you can do to make it clear is that you can do x times x and then space star x times x. So that way it's easier on the eye. So you can say you have 3 of those plus 1 lone x or something like that. I don't know. You got to have 7 x's there. Oh yeah, that's 5 and then 2 more. Times x times x. Yeah, divided by, and then again, you can do the same thing you did, 1 times 2 times 3 times 4 times 5, copy that and put it there and then add in the, yeah, okay, that's fine. 1 times 2 times 3 times, yeah. Up to 7. Now, I want to be sure that everybody's following along. Even though Jaden is coding, every one of you should be able to do exactly the same thing, right? Cold, meaning that you open up your laptop and you have Xcode or something like that. You should be able to just do this, right? Because is everybody confident so far? Can everybody just do this on your own? Yeah, I know Mia is nodding her head. I want all of you to say yes or no. Right, Kiki, you good? You good so far, Kiki?
Yes, I'm trying to type at the same time and practice on my laptop, like type the same thing.
Oh, good. That's yeah, fantastic. That's what everybody should be doing. Everybody should be doing exactly what Kiki's doing. Okay.
I actually have a question.
Yes, Jiangwan.
Can we use the
Yeah.
in C++? Can we not use the exclamation mark for the factorial?
No. Unfortunately, no. It's it's math. Because exclamation has meaning in C++, as you'll find out. Exclamation, the exclamation mark stands for the not operator. So because you can have Boolean types, right? So just like you have integer types, character types, and so on, you can also have something called a Boolean type. A Boolean type only has 2 values. An integer can have many values, right? 0 all the way up to the maximum number you can store in the bit, right? In the bit pattern. Yes. A character has different values, A, B, C, whatever you want to put in there. Like that, if you just want to store a value that can only take 2 things, either true or false, right? That's also a data item, right? Is it true or false is also a data item, isn't it? So suppose you want to store a lot of true false values, right? So if I have a list of students and say, pass, fail, and I just say, I just want to store whether they passed or not, true or false for each student, then I don't need to store a lot of bytes for each student. I don't need to store a score or a number. I can say I only need 1 bit to store whether a student passed or failed. Yes. So in C++, you get what is called a Boolean data type. A Boolean data type says this is just a true or false value. And so a true or false, which means that, well, I've got a value now. It's a data type, true or false. Now, what if I want to do logical operations? I want to do this if this is true. I want to do this if this is false. That means you got to test it. So, or if this is not true, how do I test it? So you want to take a Boolean value and say, I want to take the Boolean value and flip it. I want to say true. I want to say not true. So that exclamation mark is actually the not operator. Okay, it'll take a Boolean value and invert it. So to say, I don't know why the exclamation mark was used there, but historically exclamation is used for inverting a Boolean value. So unfortunately, you can't use it in math terminology like a factorial. Good question though. It is very tempting to do that, but yes, you can. All right. So far, is everybody okay? Now, if you run this program, you'll actually see the output. Now, before running this, you can. Why don't we run this in our head and let's take a guess. Random, people can just take guesses as to what it's going to print. You don't have to come up with the exact values, but you can say what you expect it to do, right? You could say, well, first it's going to print the systems value, which is 0.5, and then it's going to print the value calculated using one term. Then it's going to print the value calculated using two terms, and you'll see how the more terms we use, the value we calculate changes, right? So that's what we're going to see. So is everybody okay with this? If everybody, we can run it now, right? So if we run it now, you'll actually see, and increase the size of the console too. Oh, actually, we get it right there. Okay, so. Oh, wow, look at that. Look at that. This is incredible, isn't it? Because we only use 4 terms. We only use 4 terms, and already the series converts to the correct value. Now, this is not a case. This is not the case with many expansions. Okay. So in fact, in theoretical mathematics, because I know this because I was sitting with my son when he was in high school. He had a problem saying, what is the best series to use to calculate the value of this function? Okay, and the answer to that question is to because you can have this is just a Taylor series expansion. This is one way of expanding sin x, right? This is one part. There are many different ways, many different expansions for sin x, and this is one of them. And so, if in a computer or a calculator, if you want to calculate the value of sin x, you got to use one of those expansions, right? So obviously, an engineer is going to ask, well, which of those expansions am I going to use? I can calculate sin in so many different ways. Which one do I use? So the one we use is the one that requires us to do the least number of calculations to get the correct value, or the least number of calculations to get the value we want. That's most accurate, right? So we want a series that converges to the correct answer as quickly as possible, right? If a series converges very slowly, meaning you have to calculate several thousand terms before you even get to the correct answer, that's a slowly converging series, right? But this series is actually a very quickly converging series. We only use 4 terms and we already got to the right answer, right? But technically speaking, that is not the right answer because it's not 0.5. It's actually something like 0.500043. We still haven't gotten to the right answer, but it's still good enough for us because practically speaking, the compiler rounded things up for us and said you've got to 0.5, right? So now you see the more terms we use, the more accurate our answer is getting. Yeah. Now, in your quest, what you have to do is essentially write a program similar to this to calculate e to the x. And e to the x expansion is a lot easier, simpler than sin x, because e to the x is one of the simplest expansions you have. 1 plus x squared over 2 plus x cubed over 3 factorial plus x to the 4. No alternating plus minus signs, and all the powers of x are steadily increasing by 1, and all the factorials also. So it's a simple expansion, and it's going to be super duper easy to implement, but it's going to be very similar to this. And the challenge there is to implement that without using the POW function, right? Just like what we've done here. You got to say, this is how I calculate it. And you have to calculate e to the x using a certain number of terms. I think it's 5, right? In the quest, I say calculate e to the x using 5 terms in the expansion, right? And in the quest, what you have to do is we shouldn't do any cout statements in the place where we calculate the function. You just calculate it and return it. So what would happen is that now you can go to this function, okay? Comment out line 26. Comment out line 26. So go to the beginning of line 26 and put 2. Yeah, no, that can be there. Line 26. Yeah, comment it out. No, not there, not there. Comment out. Oh, I say we've never done commenting out a line before, right? If you have a program and it's got lots of statements, and you don't want a certain statement to be executed, you can put 2 slashes in front of it. That line is said to be commented out. The compiler will not look at that line. So you go to the beginning of line 27, beginning of line 27, line 26 now, line 26, and 2 forward slashes right there. Okay, that means that line is now disappeared. The compiler won't see that line. Okay, now do the same thing for, hey, by the way, how do you have so many val equals? Oh yeah, that's fine. That's fine. Yeah, I got to increase the size of the font. Just give me 1 second. Oh no.
Can I ask
I
a
got to increase
question?
it on no 1. Okay, good. All right, good. Yeah, sorry. Go ahead. Someone had a question. Shadi.
Quick question about the return statement. What happens if we don't put
Yeah.
in the return 0.0? Because in the console, we don't have, nothing is 0.0. Like it didn't return 0.0.
Yes. Okay. Now we are going to fix exactly that problem now. If we didn't put the return 0.0, the program won't even compile. No, we can test that. Put a comment out return the return statement. Comment out the return statement. It's not going to compile, right? If you compile it now, the compiler will say, hey, this function is supposed to return something, right? It says it's a non-void function. A non-void function means it's a function that is not void, a function that is supposed to return something, right? And so the compiler says, I can compile this for you. I can turn this into binary code because you gave me a function that is supposed to return something, but you're not returning anything. Does that make sense? Okay, so it's got to return something. So put the return 0.0 back, but we're going to fix it now. We're going to change it. Okay, so now comment out all the cout lines because we're not going to do any couts in the internal functions, right? So comment out all the cout lines. Put comments in front of the 26 and all of them. Right, and then instead of return 0.0, just return val. Now, one thing you'll notice here is that we only commented out the cout lines and we calculated val 3 times, but the first 2 calculations of val not even being used, right? We calculated val, but not doing anything with it. And then we recalculated and reset it. And only the last calculation we return to the user. Yeah. So the previous, so you can comment those out also. The first val equals, that's on line 29, line 29. You can comment out line 29. No. Peter is here for breakfast. So, you want to see? Peter. Here. No. All right. It's cold. All right. So so is everybody okay? So comment out the second one also, line 32, line 32. All right. Now go to your main. And yeah, in your main method.
Sorry. Oh, right.
Oh, yeah. Comment. Yeah. No. What you were doing was right. Jaden, comment out the first one also. Yeah. All right. Now let's go to your main. And you here now you see my sign is not going to print anything, right? My sign is basically just going to return a value to you. So if you run it now, nothing is going to happen. If you run it now, nothing will happen, right? So run it. Is it running? Why is it not running? Oh, we didn't show you the console because there's no output, right? So Xcode is funny, right? So the program ran, but it didn't create any output because there's no couts. And therefore, the Xcode says, there's nothing in the console. I'm not going to show you anything. So now, in order for it to show us the console, we need to print something. So in our main, we're going to say, yeah, right there, right where you have your cursor. No, right where you have your cursor, you can say cout, and then space left shift. And then you can, within quotes, you can say my sign, right? In fact, you can copy one of the previous couts you have. Let's say, take it from line 30 or something. Right? Triple click on line 30 and put it there. Yeah, put it there. And then, yeah. And then, yeah, get rid of, tidy it up a bit. You can get rid of, there, that can go. Cout, and then change sign off to my sign off, right? It's our calculation, my sign off. All right, and then hey, didn't we calculate? Yeah, all right. So the next line where you have my sign, you call my sign, right? That needs to go before the cout line. So triple click that line, triple click that. Yeah, copy that before the cout line. But cut it. Command X. Oh, actually, you know what? We can. No, in fact, we'll do something even better. Okay, yeah, cut it from there. Okay, now where you say val, change that val. Yeah, double click on val. Double click. Yeah, paste it right there. Oh, that's what you did before, and it wrapped around. I didn't see that before. And now get rid of the line 42 because we don't need that, right? The line 42 can go. I'd like to see it all on one line. Oh, actually, you know, as soon as I said that, it happened. No, it didn't. How come it's coming up on 2 lines? Oh, because you got a semicolon there. All right, because it needs to have, yeah, get rid of the semicolon after that 6.0 open close parentheses. And still it's on 2 lines. Oh, all right, okay. Now put a semicolon at the very end. Oh, I see, and yeah, no, that's all good. That's all good.
Use of undeclared identifier X.
Hmm?
Yeah,
Oh, no, it shouldn't be. Where's the X? Oh, you say instead of X, you can say 30 degrees, or you can say 30 degrees. And in fact, you can put that inside the quotes itself. Yeah, that'll also save us some space. So my sign of 30 degrees. My sign of 30 degrees. Change that my sign off to my sign of 30 degrees. 30 deg. 30 deg. 30 space deg. Okay, and get rid of the double less than 30. Oh, in fact, you can also get rid of, yeah, you can combine the radians using 2 terms. Everything in one thing. Yeah, okay, cool. No, you can get rid of that too. You can get rid of the left shift before that. My sign of 30. No, that was correct. Command Z, get that back. Command Z. Yeah, Command Z.
Yeah,
Command Z. All right, now get rid of the after the 30 degrees, get rid of the left shift operator. After 30 degrees, yeah.
Left. Oh,
there you
right
go.
here.
Get rid of that. Yeah, and then also the 2 quotes. The 2 quotes can go, so that the entire thing is a single sentence. Yeah. All right. Okay. There you go. Now, if you run this, you will actually get the value that is calculated by us using, right? So if you run it now, and it's not using 2 terms, right? It's using 4 terms. It's using 4 terms, isn't it?
Using 4 terms.
Yeah. Okay. Now you can change this to instead of passing math pi over 6, that is 30 degrees, you can actually ask the user, say, what is the value you want the sign for, right? So you can see out, enter the value for calculating a sign. And on the next line, you're going to do C in, read the value in. And then the next line, you're going to pass that value to your function, right? And the next line, you're going to print it. So you got those 4 lines, and that is your entire interaction. You guys, so do you want to do that? You want to do that? It's very easy, right? Because you're going to be doing that for calculating compound interest and so on. You're going to ask the user, right? So let's put a prompt right at the top. Line 42, hit enter, right? And you print the prompt saying enter angle, right? So C out, double left, C out, left shift, enter the angle or enter angle. Enter angle. It's got to be, it's a string, right? Double quote and then capital E. Enter. Angle in radians. How about this, right? Why don't we do angle in degrees? Okay. Why don't we do angle in degrees, right? Angle in degrees. Say angle in degrees. No, angle in degrees. Angle in degrees, not radians. Angle in degrees. Oh, is it boring? Mia is yawning, so I want to make sure that all right. So is this, are you guys all engaged enough to? If I'm boring or if I'm putting you to sleep, you should let me know, okay? Because then I can change the strategies or say something interesting at the very least, okay? So please let me know. I don't want any of you to fall behind, okay? Because this is critical. These initial parts of the code, you have to stay in step, and it'll like be solid foundation for you. Okay. All right. Now semicolon right there. semicolon right there. Now above that line, we want to read from the user, right? So let's say you say int degrees. No, int degrees, because we want to create a int degrees, int space degrees. We want to read in degrees from the user. Now semicolon after that and enter. Okay. Now after your cout, when you enter the prompt, you can now do cin right shift into degrees, right? Cin. Now after line 44, right? No, after line 44, you got to print the prompt and then read. Okay, you can't read and then print the prompt.
Okay.
Yeah. Cin right shift into degrees. No. Oh,
Okay,
I see.
so
Oh, I see. You just say degrees right there. No quotes. Just say degrees, because it's going to cin is going to go from the keyboard right into a variable, right? From the keyboard right into the variable. Cin right shift into the variable. All right. Now semicolon enter. Now at that point we would have printed the prompt, read what the user typed in, and put that into degrees. Okay. Now what we want to do is blank line there. And then say comment, start a comment, and say, let's say convert degrees to radians. Say convert degrees to radians. Convert degrees to radians. Now we know pi radian is 180 degrees. Yes? We know that.
Yeah.
So 180 degrees is pi radian. So what is x degrees? So x degrees, or n degrees, or whatever it is, degrees, right? So it's going to be degrees divided by 180 times pi. That's the number of radians, isn't it? Yeah. Because 180 degrees is pi radians. So how many radians is 1 degree? So for 180 degrees is pi radians, or pi radians is 180 degrees, right? Pi radians is 180 degrees. So that I need to chop it up into 180 bits. Pi radians is 180 degrees. I need to cut it up into 180 chunks, and each one of those is 1 degree. Does that make sense?
Yeah.
Okay. So 1 degree is basically 180 over pi radians. Yeah. Okay. So on the next line, you say double radians equals 180.0 divided by degrees space times m underscore pi, max pi. Lingchen, you got to speak up, okay? I'm not looking at the. I'm looking at these just by chance. Some of these messages appear in front of my screen, okay? You should feel free to interrupt, okay? Anyone who talks, like Mike was talking before, right? So just feel free to talk. That's my question. What does slash do as an operator? You guys are having a separate conversation in chat during class? I don't know.
Yes, we are. Sorry.
All right, okay. You should feel free to have a verbal conversation, okay? Have a verbal conversation, and I'll just stop and during the time, so you can have a conversation. That's perfectly fine, okay? That's what this class is here for. This class is here for all of us to interact with each other and learn off each other. So please feel free to talk. Don't use the chat, because for 2 reasons. I can't see the chat. Many people are actually watching the lectures and they can't see the chat either. The other reason is because chat will not get recorded into the YouTube. So if you discuss interesting things in chat, they will not be available to other students who see it later on. So please, is your whatever is discussed in chat, is that issue resolved?
The main question is, what is the backdash operator and what does it do?
Backslash operator?
Yeah.
Nothing important.
Right.
Just chat.
Who said that? Yeah, go ahead.
Yeah, never mind. Just continue.
Yeah, no, that's fine. So backslash is basically used inside of strings to tell the compiler the next character following me is not a real character, treated specially. That's all. It's called the escape character. So you'll only see this in C++ inside of strings. Are you talking about backslash or forward slash? Because it's 2 different things.
Yeah, the backslash.
Yeah, the back one. Yep.
Okay. Backslash is called an escape character. And escape means escape from the normal way of treating strings. The next character is not a regular character. You treat it separately, especially, which means that after backslash, if I have n, that actually is a new line character. If after the backslash, if I have R, that's a return character. In fact, this is a special backslash character for you. Backslash A is the bell, right? It's going to be the bell sound on your computer. So let's put a backslash A in there, and when he runs this program, you'll hear the bell, bam, like that. Oh, okay. So let's put the backslash character, backslash A. So put a backslash A in front of my sign, okay, on line 49. On line 49. Yeah, put a backslash A. No, not a forward slash. No, inside the code, because backslash has got to be inside a string, right? So inside the code, backslash A. Well, if you put it there, it looks like Amy. Put it at the end. Put it at the end. No, it's backslash. Okay, backslash. You can put it anywhere, by the way. No, not forward slash. Backslash. Yeah, backslash A. All right. So now when we run this, we're going to see backslash A is not going to be visible. It's only audible. Okay. When we run this, we'll hear a bip sound. Okay. That is the backslash A character. Now, let me see. Have we got everything else? Backslash A. Yeah. Okay. Now, that should work. Okay. Now, if you run this, it'll ask you.
It says, unused variable.
I'm sorry. Yeah, we need to change inside my sign. The parameter is not 30 degrees anymore. It should be radians, right? We calculated radians. That's what we need to pass to my sign, right? So we need to pass my sign, get rid of the m_pi and stuff like that inside of the parentheses, and say radians. Okay. Now, if you run this is okay. Yeah.
And
if
should
you run
I
this,
change
it'll
this
ask
to?
you.
Should I change this? It says my sign of 30 degrees radians to something else, or leave
Oh
it like that?
yeah. You can just say my sign of your angle is. Thank you. Good point, Jaden. Thank you.
And just get rid of the forward term.
Angle. Your angle. No. Using 4 terms is correct. Because we are using 4 terms, right? Command Z. You'll get it back. Right. Okay. All right. So if you run this now, it'll ask you, and all right. Now, if you enter, what is it, 30 degrees, you should get 0.5. 30 degrees is 0.5, isn't it? Wow, that is funny. All right. So now we're going to debug it. All right. It's not working. So we got to figure out what the hell is going on. Why is it not the value that we want? Okay, my sign returns a double, and it is calculating the right value. Double radians equals 180 degree, 180. Oh, it's degrees over 180 times pi. No, it's not. Yeah, you just need to invert the order. So it's degrees over 180. Oh, is it degrees over 180? Yeah, degrees over 180 times pi. 180.0. Okay, now that'll work. Okay, so 30 degrees should give you 0.5. All right. Actually, put a space in front of the 0.5 in your there. There you go. Put a space there. Oh, why didn't we hear did you hear a bell? Run it.
I'm using the like a online thing, and I heard a bell too. So
You heard a bell? But we
I
should
did.
hear a bell here. Who heard a bell, by the way? Who? Oh, was it Noah?
That's me, Jose.
Oh,
Professor.
Jose.
Yeah.
Yeah. So Jose heard a bell, but we should hear a bell here too. Can you run it again?
Okay.
I didn't hear it. Did you hear it, Jaden?
I didn't hear a bell.
Didn't hear a bell either.
Yeah. Well, the bell should ring. Okay. Well, the thing is, it's not. You can't hear the bell inside of Xcode because Xcode is probably doing something. But there is a way that you can locate the binary. And we went over this in a previous class, and I'm not going to do it now. Unless all of you want it, you can locate the place where the executable file for this program has been created and stored. You can go to that place and run that on the terminal in the Mac terminal. When you run in the Mac terminal, you will definitely hear a bell. Okay. So I don't want to show it unless you guys want me to show you. It's there in that walkthrough that we did before. Okay. So if you look at that, orientation video, you'll actually see how you can locate the file and actually run it on the command line. Okay. And then you will absolutely hear the bell. Now you can run it for any angle, and you can say, well, what is the sine of 90 degrees? Should be 1, isn't it? Sine 90 is 1, isn't it? So if you type 90, you should get 1. So run it again and type 90, you get 1. You type 0, sine 0 is 0, you should get 0, right? So just using 4 terms, we've created our own sine calculation. Now, does that make sense? Now, this is essentially what you're going to do in quest number 3 for one of your mini quests, where you're going to calculate e to the x. Instead of sine x, you're going to calculate e to the x. And when you have your file ready, you're going to go to this file, sine.cpp, or in your case, it's going to be called etox.cpp or something like that. You're going to calculate, you're going to grab that file and drop it into the questing system, and that will give you a trophy. Does that make sense? I think it's a reasonably useful walkthrough for quest 3 too. Yes. Okay. Quest 2, many people get stuck because most of the time they're just fighting with the grouping of operators, right? The limerick quest is how do you group these operators together so that the left-hand side is equal to the right-hand side, right? So putting the parentheses around, you should calculate this before you divide and so on and so forth. When you get that right, your limerick will work out. But getting that right is basically just thinking through the problem and saying, oh, how should I group these things together? Now, is this okay? Was this a reasonable enough introduction for you guys to, on your own, do something like, compound interest? So except for your problem, you're not going to be asking for enter the angle. You're going to be asking the user enter the what is it? Yeah, number of years, principal amount, and so on and so forth, right? So we have at least 2 ideas, and you can Google for other ideas, right? Maybe you want to calculate a tan x or some other mathematical function, or you can even calculate some, weird things like, oh, I'm going to calculate your year of birth by asking you some questions, right? And obviously it can be, you can't ask obvious questions. You can say, enter, I don't know, enter the number of years you went to college, or enter the number of years you went to school. Some, indirect questions. And based on that, you calculate, something and print it out. Hey, Nate, what, yeah, you have a question? Can hear you.
Can you hear me out? My bad.
Yeah. Okay, cool.
Yeah. So I don't know about everybody else. If the Taylor series is a little bit complicated, or if like sine functions are a little bit complicated, there are lots of easy things that you can do. If any of you are interested in like bulbs, controlling bulbs and stuff, there's a language called C within C++. It's an earlier version of C, but it makes things a lot easier. Like I tried it last night, and it made things a lot easier. If any of you are interested, this might be a little bit complicated. Thank you.
Fantastic. In fact, well, Nick, why don't you share your screen and show a couple of things? You don't have to show all of them, just one or 2 of those. And in fact, you had something to show also, right?
Yeah.
Hey, by the way, Jaden.
Yeah, sorry.
And also, 1 minute before I hand over to you, Jaden, thank you so much. Okay, you did a fantastic job today, and typing ahead and being very patient. And your code looks so clean. In fact, what you should do is also share that code on Reddit and saying, this is the code we worked on today, and feel free to copy. You can put the code on a public site like GitHub, or even on cpp.sh, and get the share link and say, you can, or onlinegdb.com. You can go, here's a share link. You click on that, you can go to the code that we worked on in class today. Right. Okay. So please share. It's absolutely fantastic. Okay, so great job. And Nate, if you can share. The only thing to be careful about in all these expressions that you're going to calculate now is that make sure that those expressions don't require looping. Okay, looping or branching. Let's try today. What time is it now? Oh my gosh, it's 10:08. Oh wow. Yeah. How did we waste so much time today? Maybe I talked too much. Okay. So thank you all for sticking around, right? You guys don't have other classes?
We did.
No.
I probably have to hop
All
in.
right, okay. I'm so glad. I'm lucky that you guys have, chosen this class to, not intersect with. When I did my schedules, when I was back in doing college, I made sure to pick classes that were at least had 1 hour between them. So cool. Thank you. All right. So still, Nate will share his screen and share some pointers now. And please do, Nate, take the screen and share the screen. And also after that too, if you guys want to share your work, go ahead. Okay, we won't stop the recording until all of you are done. The last person to leave, just call me and I'll stop the recording. Okay, until then, this arena is yours. Okay, play with it and have
Professor,
fun.
I need to
Thank you.
hop on another
Yeah.
call. Is that okay if I leave?
The class is over, Shadi. Now you're here out of your own kindness. Okay, so you should feel free to disappear anytime. Thank you all. Thank you so much.
Thank you.
Okay, all of you, right? And Nate, after this, you should also feel free to share this in the forums so that people like Shadi who left will still be able to, benefit from what you're sharing. Is that okay?
Okay. Yes.
All right.
Can you hear me?
Great. Now I'm gonna turn this. Yeah, I'll be here, but I don't want to be in your face. But I'll hear what you're saying and I'll watch the video later. Okay. All right.
Professor, so can we also take this?
Yeah.
Do we also take this time?
You have a question?
Are we allowed to take this time to also, if we need help with Quest2 coding, or no, we can't do that?
Absolutely. People can stick around. The only thing you shouldn't discuss when questing is don't discuss actual Quest code. Okay, and never show your code to someone else and say what's wrong with it. Whether it's even not our classmates, right? Don't take your code and show it to your brother, sister, friend, nephew, niece. No, nobody. Okay, nobody should look at your code. Only you. And I'm saying that for a reason. Okay, CS2A and 2B, you have to do that yourself. When you get to 2C, you can show your code to other people. Well, even 2C, I discourage them, right? But when you're a professional, obviously you're going to write code and show it to other people and say, look at it and debug it together. But until then, please don't do it, because that is a luxury that will only be luxurious if you haven't enjoyed it before, right? If you, if you had an iPad all your life and you're just given an iPad, but in my generation, we didn't have iPads when we were growing up. And when we were given an iPad, we said, oh, that's fantastic, right? So you want to have that effect, as well as it's going to be useful, right? It will be much more useful. Is that okay with you guys? Can I just turn around and? Awesome. Just call me, okay? I'm going to be here. Just call me if you need help, and I'll come and help you. Otherwise, I will see you on Tuesday. I hope you're all coming back. Okay. Thank you.
Thank you.
Thank you. Thanks. Bye.
Is anyone on Quest2 or how are you on Quest3? Because I'm still a bit stuck on Quest2.
I did the same thing you did, Jaden, like set it up. And now I'm just like actually trying to like understand it and complete it. So
Yeah, I'm having a bit difficult time with each one.
can agree.
I do have one question. For Quest, I think question 2, it was something about the
limerick?
The limerick one. We're not supposed to print anything, right? It just kind of goes. The professor had some what do you call it, the code or the paste and copy code. He was just saying we don't actually have to print anything, right? He has some kind of argument that kind of does what it needs to do to print out what it should.
Yeah, I would assume so. I kind of just go off the template. Like I type the whole template and then I like kind of read it and just edit it. So it doesn't seem like it's asking us to.
Okay, so you just basically write in your code function and then.
Yeah, I think it
let
just
do it.
wants us to get that answer of, what is it? For it to be 9 squared, so 81.
Okay,
Yeah.
sounds good. Thank you.
So for the drawing the cat, is it set up as std .c out, or is it just c out in order to print out the picture?
I used what we've like first been using, which is just std. I don't think you have to. I just use std the c out personally.
Yeah.
So
Because it keeps returning as expected expression, which is
Yeah, I would just try with, if you didn't use STD, just try with it, honestly.
yeah. I did it with std out, but it keeps returning as expected expression.
Can I see your code? Maybe I can see what's,
Oh,
Hey,
that,
no. Hey,
oh,
guys,
sorry.
yeah.
please, please
We
don't.
can't do that.
Sorry,
We can't
my
do that.
bad.
I'm
I
just,
forgot.
yeah, we can't. Unfortunately.
I was just kind of go off the template and, like I said, I just kind of just copied exactly how it is and just try printing like that first part, like the dashes. And then if that works, then do the next one. I think what you're getting is because you're using one of the escape characters.
Yeah, I do std out, and then
Just if you look up what I did, I don't want to give you like the exact answer because I was getting the issue of using the escape character. Just look up like how to ignore escape characters and it'll literally give you the answer on how you can do that. And
I see.
it'll look weird, but when you actually print it, it'll look like the cat. So I hope I didn't give too much there, Professor. Hope that
No,
was helpful.
No, that's perfectly fine. Yeah, that's the
Okay.
kind of help that would be useful. Yeah, thank you.
And also what helped me is that instead of doing it all in one line, I actually, hit enter so that you can kind of get a new line and then type in the next one so that it
Just
helps
kind of
you at least,
visualize
yeah,
it.
visualize it.
Yeah, that's what I did too. It's annoying to do all those lines, but it does make it look like how it should be.
All right, I'm gonna hop off. Thank you, guys.
I'm about to hop off too.
And-
Thank you, Professor.
actually, just
All
one
right.
more question.
Okay.
Oh, yeah.
Okay.
Yeah, I just wanted to make sure. And when we're putting in the strings, like string C out, do we do it under void draw cat, or do we place it into the main console?
If you look at the template, you pretty much what you were doing today in class. You do it in the function draw cat, because then you're invoking everything you wrote in there into your, like, you're calling it in your main. So your main will just print out everything that you did in that function.
Okay.
So I did everything in the draw cat.
So void draw, yeah, void draw.
Yeah.
Okay, thank you so much.
Yeah, no problem. I'll see you guys later.
All right, yeah, I'm gonna hop off. Thank you, everyone.
Professor, are you still there?
Yeah, I can switch it off now. But did you have a question, Tim?
Oh, I did. I didn't want to interrupt their conversation there, but
Oh yeah, no worries.
after,
no worries. Okay, hang on. Yeah.
Sure. After class on
What's up?
Tuesday, I did I reinstalled Windows 10 on the device I'm using, and I got everything to work fine. But I had a question for you. I don't know if you can answer this in VS Code. Is it right if I share my screen here?
Yeah, sure. Go ahead.
So yeah. So I'm trying to set up like a project file in a way that like is a good way to do it in the future, I guess, or like typical way of doing it. The way that I can I only get this this VS Code to work right now is there's a launch.json file, and it has to have like a reference to a project. And I don't understand what's actually going on here, because I have this inside of a Hello World project, you can see here. But if I move it out of it, none of these other projects work. So like, for example, I can run this sign.cpp that I was calling today. Oh, sorry, go ahead.
I see. Okay. So I think the way this works is that every project that you create will have its own JSON file, the settings file in there. So is .vs code? Oh, I see. Oh, how come you have you have nested folders? What is the top level .vs code, and then
I'm not sure what I did wrong
where's
here.
your folder? Can I see can I see a folder structure in Explorer?
Yes, of course. So I should have in Drive CS2A folder, and it created the VS Code folder. I've got these two separate projects.
And what is the VS Code folder? What does it have?
So it has the settings and the JSON.
Oh, I see. I see. That's just it. Okay. All right. Now I assume you have VS Code in your path. Do you have VS Code in your path? Can you just go to can you just type code something and will it enter your, go to your command.com and say code something, code dot, just say code dot in command.com. Code space dot. Yeah, code space dot. Yeah. Oh, actually, it is in your path. That's great. Okay. So now, yeah, exit. Don't. Yeah, exit. Don't save anything. Okay.
Sure.
So create a folder here called test. Create a folder right there called test. No, not there. On your desktop itself. You will delete this folder later, right?
Yeah. So folder called what?
Test or something.
Okay, test. Okay.
All right. Now, now go to your command.com window, and then change into cd/desktop/test. No, it's got to be a cd space backslash. Yeah. Yeah. No, I think it's capital D. Maybe it's cd space capital D, cd space backslash capital D, and then hit tab. Okay, desktop is there. Okay, enter. How come you don't have? Oh, yeah. Of course, users. It's not in your root directory here. Okay, so cd. Where is your desktop? Your desktop is /users/Tim Bloom or something like that, right? So you got to go to your cd. Yeah, there you go. So you just say cd desktop right there. I think. Yeah, /capital D and yeah, cd space capital D and tab, capital D and tab, hit tab. Yeah, there we go. Right.
Okay.
So enter.
There we go.
Now you can cd into test, cd space test. All right. Now you can do a code space dot, which means what you're saying is start the VS Code editor in the current directory. That means it's going to create a project called test right here, and trust the others and so on. Okay. Here, create a file. Just create a file. Let's say hello world.cpp, right? So something like that. Hello.
CPP here.
Okay, enter. Yeah, can you edit that file and just say, main, whatever, int main, hash include, put in the standard boilerplate. So hash include, I hope this, angle bracket IOStream.
IOStream, and then
enter, using namespace. And then int main, open, close. Yeah, and you can just say cout hello. And out. Yeah. Okay. Put a new line after the hello just in case. It doesn't matter because we're not hoping to run this. Okay. Okay. Good. Now save it. Now, are you able to run this here? Let's
see. So if I hit debugging those. It comes in a weird terminal too. Yeah.
Wait, oh wow, they actually did it. It seems to have compiled it.
Where?
Great. Now go back to your terminal.
Yeah.
No, terminal. Command.
So hello,
command.com. No, in your command, in your command prompt. Okay. Now, it lost the directory now. CD to desktop. Oh, there you go. Now do a dir and hit enter. Dir, enter. There you go. Every project has its own .vs code file.
Right.
And you say type so cd to .vs code, cd space .vs code, tab, code, tab, enter. Now do a dir.
Oops. Did I take
No,
that?
dir, one I.
Mistype.
Okay, so it's got these JSON files, task.json. You can see what's in here. Type task.json, type space, type type space tasks T and hit T and hit tab. Enter. Okay, so that's the file. So yeah, everything is really cool.
Okay.
It's basically set it up. So VS Code gives you the default configuration. So every project you create is created in a file inside of a folder in VS Code, and in that folder it's going to create a .vs Code directory which contains all the control information in JSON files.
Okay.
Now if we go back to your project, now I can make sense of what you have there.
Okay.
I think.
Hopefully. Because
So,
my
and
hope
what was your question?
well, yeah, my hope was to try and keep it in the CS2A folder, which is like in a Google Drive. I don't know if that's messing it up somehow, or like.
No. Oh, you want to keep that in the Google Drive?
Yeah, because it keeps like a local folder, a local Google Drive folder here. Watch, this is like in.
Oh yeah. You can totally do that. Hey, if you have a local mount of the Google Drive folder, you can do that. So you can just go into CD to Google. What is that folder? How do you get into that folder? Open that folder in command.com.
Yeah.
So what is that folder called? So in fact, in your home directory, just say dir and hit enter. In command.com. Yeah, dir here. Do you have Google Drive listed here?
Doesn't look like it.
Yeah, see, that's what I was afraid of. It's not
like
an actual physical.
Right.
Yeah, it's not a mirror of your Google Drive. It's an extension that's talking over some pipe or socket to the actual Google API. How about if we, maybe it does have a mirror somewhere. It has to have a mirror, right? Because if you have a local copy, it lets you edit offline and all, right? It must be mounted with some name.
Yeah.
Maybe it's under your home directory.
In fact,
G. All right. No. We know. So yeah. All right. Now go to your command.com. I know what it is.
Okay.
Okay. Now, it's your command.com.
Oops.
All right. Say hit G : and hit enter. So type G : enter. All right. There you are. Okay. Now do a dir. dir. Okay, now create a folder called CS2A. mkdir. I think it's mkdir. I've forgotten the DOS command. Of course, you can also do this in Explorer and in the GUI, but you can say, CS2A. Yeah, enter. Oh, I think it's MD, maybe MD.
MD.
Oh, you can't create folders like this? I don't know how do you create. I don't know how you create.
Find it.
All right, do it in the Explorer. Do it in your GUI with the mouse. Yeah.
So actually, there's one here already.
Oh, you actually do have a folder. You have a folder.
Oh, but it's in a subfolder called My Drive. So if we did that, could we go to My Drive and then check to see?
No. Oh, I see. Yeah. That's right. Yeah. I think you have to CD to G. Yeah, CD to /My Drive / my space. Hit tab after MY. It should. MY and tab. Yeah. Okay. There you go. Enter. Yeah. Now do a dir. dir.
So CS2A should be.
Yeah. Okay. You have a directory called CS2A. So go into CS2A.
Is that right?
Enter and then do a dir again.
So right now, yeah.
Okay. So there you go. There's all your files.
Yeah.
Yeah. Now you can create a brand new one. So you can say make dir test or something like that. Make dir test.
Before I do that, can I
IR test?
Maybe I'll just drag out what's already in there because I don't know how this.
Yeah, sure. Go ahead.
Steps. I'll just
go ahead.
It's out here for a second. Oops. Move all those. There we go. So now we can. You said it was. What was the command again?
Just mkdir. Let's make directory space test. You can delete this directory later. So test. Yeah. All right. Now you can cd into test. And then you can say code space dot, and it'll create a project right there.
Great.
There you go. And then if you go to your Explorer, you should see all the .vs Code files and the JSON control files right there.
Yeah. And as long as, yeah.
Yeah.
But there's the test folder. Cool.
I think Explorer doesn't show you files that start with a period, maybe.
Oh,
They're
maybe.
hidden files. Maybe
Mhm.
that's why. I'm pretty sure it's in there. The control data is in there.
Yeah, yeah. It doesn't look like it's because we haven't created anything yet here. We do I say a test CPP.
Yeah,
It
yes,
should show up
and
now.
it'll definitely be there. You can
Awesome.
just save it and it'll show up. Yeah.
That's super helpful. Thank you.
Did that help?
Yes.
All right.
All right.
I'll see you on Tuesday.
All right. Yep. Thanks again.
All right. Happy coding.